In August 2012, the world celebrated. Voyager 1, the small spacecraft launched in 1977, had crossed an invisible boundary more than 120 times farther from the Sun than Earth. Headlines called it the first human-made object to leave the solar system. But in another sense, the headline was wrong. Voyager had not reached the true edge of the solar system, not even close. The real boundary of our star's domain was still far ahead. So far ahead that Voyager 1 will not reach its inner edge for about 300 years, and may need roughly 30,000 years to pass through it completely. By then, it will be a silent piece of metal, long dead, drifting through a structure almost no one has ever seen or even thinks about. That structure is called the Oort cloud, and it may be the largest, emptiest, and strangest part of our entire solar system. The problem begins with the picture most of us carry in our heads. It is not. The planets are only the crowded inner neighborhood. Neptune orbits about 30 astronomical units from the Sun. 1 astronomical unit is the distance between Earth and the Sun. The Oort cloud may begin a few thousand astronomical units out and may extend to 50,000 or even 100,000 astronomical units. At that distance, you are not just beyond the planets. You are at the dark shoreline of the Sun's gravity. And unlike the planetary system, the Oort cloud is not a flat disk. It is a shell. A vast hollow sphere of icy bodies surrounding the Sun from every direction. Above, below, left, right, all around. We do not live in a solar system shaped like a simple plate. We live inside a bubble. The objects in that bubble are not crowded together. The word cloud makes it sound dense, like a fog or a blizzard of ice. The reality is almost the opposite. The Oort cloud may contain trillions of frozen bodies, but they are spread across such an enormous volume that the space between them is almost incomprehensible. If you stood on one of those objects, you would not see the next one nearby. You would see stars. These bodies are ancient. Frozen water, methane, ammonia, and carbon monoxide. Leftovers from the birth of the solar system, preserved for 4.5 billion years in deep cold. But they were not born out there. They likely formed much closer to the Sun in the crowded chaos of the young solar system. Then Jupiter, Saturn, Uranus, and Neptune scattered them outward with their gravity. And here is the strangest part. We have never directly seen it. No telescope has ever captured a confirmed image of an Oort cloud object sitting in that distant dark. The bodies are too far away, too small, too cold. They reflect almost no sunlight. Even infrared telescopes struggle because these objects hover only a few degrees above absolute zero. So how do we know the Oort cloud exists? Because it sends messengers, comets. Today we know they are icy bodies heated by the Sun. And that matters, because comets cannot survive forever. Every pass near the Sun removes more ice. After enough passages, a comet fades, breaks apart, or goes dark. If the solar system is 4.5 billion years old, the comets we see today should have disappeared long ago. But new long-period comets keep arriving. Some come in on orbits lasting thousands or even millions of years, and they fall toward the Sun from every direction, not just from the flat plane of the planets. Short-period comets, like Halley's Comet, usually come from the Kuiper belt beyond Neptune and follow the same general plane as the planets. Long-period comets are different. They arrive from above the solar system, below it, from every angle in between. That only makes sense if their source surrounds us in every direction. In 1950, Dutch astronomer Jan Oort use this pattern to describe a vast comet reservoir surrounding the solar system. The idea had earlier roots, including work by Ernst Öpik, but Oort's model gave the structure its modern form. We have never seen the cloud, and something has to knock them loose. At the outer edge of the Oort cloud, the sun's gravity is weak. There, the rest of the galaxy begins to matter. The Milky Way itself pulls on the cloud through what astronomers call the galactic tide. Passing stars can also disturb it, nudging distant icy bodies out of their slow orbits and sending some of them falling toward the inner solar system. That shaping runs deeper than anyone expected. In 2025, astronomer David Nesverny and colleagues published simulations suggesting that the inner Oort cloud may not be smooth at all. It may form a warped disk with two spiral arms, roughly 15,000 astronomical units across, sculpted over billions of years by the gravitational tides of the Milky Way itself. From far enough away, the edge of our solar system would look like a miniature galaxy, and it is not harmless. About 70,000 years ago, a dim star known as Schultz's star passed through the outer region of the Oort cloud. It was a close encounter on cosmic scales, and humans already walked the Earth when it happened. Another one is coming. Gliese 710, an orange dwarf star, is expected to pass through the Oort cloud in about 1.3 million years, approaching to around 10,000 astronomical units from the Sun. That makes it the closest known future stellar encounter, and it will pass deep into the cloud. But it will shake the cloud. Simulations suggest it could send a long shower of comets inward, elevated comet activity persisting for millions of years afterward. But over that time scale, even a small increase in the odds matters. The Oort cloud is not just a boundary, it is a reservoir of potential impacts. Beyond Neptune, those stepping stones vanish. That is what makes Voyager 1 so important. It is our scout. It crossed the heliopause in 2012. It is farther from Earth than anything we have ever built. And still, it has not even reached the beginning of the Oort cloud. It will get there in about 300 years. It may not leave the far side for about 30,000. Long before then, its power will be gone. Its instruments will be silent. So what is the Oort cloud? It is our outermost inheritance, frozen material from the birth of the solar system, holding clues to where we came from. And it is also our cage, a boundary so vast and empty that it reminds us how limited our reach still is. We can see the galaxy, we can map it, we can dream about crossing it, but before we ever reach another star, we must first face the invisible wall around our own.